I'm up about figuring out greatest common factors, and when I make a pie chart I'm in need of a protractor. The angle of elevation, thanks to my calculations, turns out to be 43, a prime number. I'm mathematicious. It makes me so ambitious. My answers are judicious, calculator never glitches. It's my mission. I get the answer right, and I'll be staying up all night just to check what I write. Mathematicious.
What the probability?
Mathematicious.
Of me not naming my T's?
Mathematicious.
When having inequalities?
Mathematicious. Hold up. Check your what?
Hey guys, well there you go, one more installment of the song Mathematicious as we begin our 7.5 lesson here with solving rational equations. Now this is actually just part 1 to the 2-part 7.5. It's a very long lesson, so I'm breaking this into 2 parts. So we're going to be looking today really at, or in this lesson, solving rational equations by cross-multiplying. We'll be doing that for sure. And also we'll be looking at some of them of finding least common denominator. That's kind of what we're doing today. A few of these as well. All right, let's go ahead and get into just a little In the Bleachers cartoon to start us off. So you got the punter here as he's kicking the his player that was holding the ball, and the coach is on the sideline over there. Go tell the athletic trainer that we need an optometrist. All right, in the bleachers. I guess it's not football season at this point, but still funny anyways. All right, let's get into cross-multiplying, solving equations by cross-multiplying. Okay, so on page 213 in your notes on the extra practice number 1, it says that we're going to solve the equation by cross-multiplying. So what we really have here is a fraction equal to a fraction, which we would call a proportion. And so we would, whenever we find a proportion, we want to just cross-multiply. So that means we want to multiply the 5 times this x plus 8, the 2 times this 2x minus 7. So we'll start doing that. So on one side of the equal sign, we'll do it this way. It doesn't matter which way you start. So 2 times 2x minus 7 is over here, which means on the other side we'll be doing 5 times the x plus 8. And now all we have to do here is distribute in. We're basically solving this equation for x now. It's back to more of a simple equation that we know how to solve. So distribute and then continue solving. So on this side we're going to get 4x from 2 times 2x, and then 2 times negative 7 is negative 14 or minus 14. Over here we'll have 5x and then 40. So 5x plus 40 on that side. We need to get the x's together on one side, the numbers on the other. So we'll start with the x's here. I'm going to subtract 4x from both sides to get the x's on this side. So I'm going to cross out this 4x with a minus 4x or negative 4x, and over here 5x minus 4x would give us a 1x here. So we're going to bring this all down. Negative 14 equals 1x plus 40. And then we just bring our 40 to the other side. So here we'll subtract 40 from both sides. And so now these will cancel here, and so we'll just have x on one side. It will equal to a bigger negative, and this is going to be negative 54. So our answer then for x is just negative 54. So now it does say to check your solutions, and here's where you want to check. You just want to make sure that the number you get for x is not an excluded value. So up here we know x cannot be negative 8. Over here x cannot be a fraction. We would say this equals 0 here, so I'd be adding 7 and dividing by 2, 7 over 2. Well, this number here, negative 54, is neither one of those. So you can keep this number as your answer. Number 2, again, cross multiply. So we can multiply the x's first. X times x will be x squared. And then multiply negative 4 times x plus 1. That'll be a distributive property. I'm distributing as I'm multiplying on this one. See over here I didn't do that. I just kind of put them next to each other and then distributed. But negative 4 times x is negative 4x. Negative 4 times 1 is negative 4. So you can kind of do that as well to maybe save yourself just a little bit of time. So what we see here is we have a quadratic equation, and we want to set this equal to 0, so we're going to need to take both of these terms and move it to the other side. So we're going to add 4x, and we're going to add 4 to both sides here. So we'll do it to that side, and we'll add them over on this side. So it's going to be x squared plus a 4x plus a 4. And that will now equal to 0 because we canceled everything out here. Well, we can try to solve this by factoring. That's probably going to be the fastest way to do it. I mean, we could complete the square. We could also try the quadratic formula, but I think factoring will be easier. So if you think about this would be the simple method with just putting x's up in front of the two binomials. What two numbers multiply to give you 4 that will add to give you 4? Well, that would just be 2. And so what we're seeing here is we're seeing x plus 2 times x plus 2. They're exactly the same, so we really only need one of these to actually solve, and we're going to set one of these now equal to 0 and then solve for that. So just x plus 2 equals 0, subtract 2 from both sides. So our answer for x is just negative 2. We might call this that there's a double root here because we do have two answers. Technically, we're getting two answers of the same number, negative 2. So we could say it's a double root. But we really just need to know that the answer here is negative 2, and we can keep this negative 2 because it's not one of the excluded values. X can't be a negative 1 and x can't be 0 from our problem. And going on to number 3, again we're going to cross multiply, but we're seeing we have binomials here, so we're going to have to use FOIL here to cross multiply. So starting with one side, x plus 1 times an x minus 6, and then the other side will be x plus 2 times the x minus 3. And now we just want to FOIL each side. So x times x, the outside and the inside, and then the last. So that's going to give us an x squared minus a 5x minus 6. So x times x is x squared. Your outside's negative 6x, inside's 1x. So take 1 away from 6, it's negative 5x for the middle, and then 1 times negative 6 is negative 6 here. Over on this side, this will FOIL down to these three terms. So x times x is your x squared here. Outside's negative 3x, inside's positive 2. So if we take 2 away from negative 3, it leaves me with a negative 1, and then 2 times negative 3 is also negative 6 here. So as we see, we have some things that are the same on each side. We have x squareds that are the same. Now those are going to cancel each other out, because if I was to subtract x squared from both sides, that's what would happen. So we're going to just go ahead and cancel out our x squareds there. We also have negative 6 on each side as well. So if I added 6 to both sides, that's going to cancel them on both sides as well. So we can just cancel out those negative 6's. So that leaves me now with the x terms here. I'm going to now see, I'm going to bring this x over on that side. So we'll now see that we have, when we add x, so we're going to add x to both sides. It cancels the x here, and over here we have taking 1x away from negative 5 is going to be negative 4x, and everything over here is canceled, so that means there's 0 on this side. So negative 4x equals 0, and if we just divide by negative 4 divided by 0 is 0, so our answer is 0 for this one. And we can keep that answer because it's not one of the excluded values. X can't be 3 and x can't be 6, so x can be 0, so we can keep this one. Number 4, again, cross multiply. So start with multiplying the negative 2 times the x plus 21. We'll use a distributive property there. And then these two binomials, we'll have to use FOIL to multiply these two. So I distribute this into here. That's going to be negative 2x minus 42. And on this side, we're going to FOIL this, so x squared for the first part. We're going to get a negative 3x on the outside, positive 9x on the inside. So I'm going to basically say 9 minus 3 is going to be positive 6x for the middle. Then 9 times negative 3 gives me negative 27 for that last term. So we do have a quadratic equation, so we want to get everything on one side equal to 0, and we need to put it where the x squared is. I'm going to bring these two terms over to this side. So here we're going to do the opposites. We're going to add 2x, we're going to add 42 there to that side. That way cancel those out, leaving me with 0 here. So I need to add 2x to this 6x term, and I need to add 42 to my negative 27 over there on that side. And then we're going to see we'll have an x squared. These will become 8x. And I got to take 27 away from 42. That's going to make me 15. So I'm going to put that up here on this other side over here. So now we have 0. All right, and you can keep going below if you have more space. I just didn't have as much space here. So I have my 0 on now this side here, x squared, my 8x, my 15 from these two. And again, we want to just see, can we factor this? That will be the easiest way to then go and solve. Factor the two binomials with the simple method. So 0 equals these two binomials. Start off with the x's. Two numbers that multiply to give me 15 that add to give me 8 is the 3 and the 5. They multiply to 15. They also add to give me 8. They're both the same sign with this positive in front of 15. They're both going to be plus signs there. You can always double check that by doing FOIL to make sure you get back to that trinomial. Now set each one of these factors equal to 0 for the 0 product property. So x plus 3 equals 0. Subtract 3 and x equals negative 3. And we can keep that answer because x cannot be positive 3, but x can be negative 3. X also can't be negative 21. So this is an okay answer to keep. Our other answer is going to be x plus 5 is equal to 0, and then just subtract 5, so x equals negative 5, and we can keep that one as well. So these two are both okay answers to keep. Neither one of them are the excluded values. Now if they are, we just couldn't keep that. That would be kind of an extraneous solution at that point if it was one of the excluded values. Okay, so here's an example of actually applying the cross-multiplying technique of solving these to a kind of real-world problem. We would call this a mixture problem because we're trying to mix something together, and people do this all the time. They're mixing different substances together to make a new substance. So this is an example of one with sterling silver. So if you ever go to the store and buy jewelry or anything that's made out of sterling silver, that's not pure silver, and it's actually mixed with copper. So it says an alloy is formed by mixing two or more metals. Okay, so an alloy would be the sterling silver. That's an alloy. Sterling silver is an alloy composed of 92.5% silver and 7.5% copper by weight. So actually, when you're buying that sterling silver, there's actually 7.5% copper in that. It says you have 15 ounces of 800 grade silver, which is 80% silver and 20% copper by weight. How much pure silver should you mix with the 800 grade silver to make sterling silver? So now this problem can be a very confusing problem to try to figure out, but if we just can remember a simple formula, then we shouldn't really have much trouble. So here is the formula that we would need to do. So it's the percent of copper in the mixture is equal to the weight of copper in the mixture over the total weight of the mixture. Now even that formula can kind of be a little confusing to remember, but one way you can kind of think about it, I think, is what are we looking for? So in this one it says how much pure silver. So we're looking for silver because in sterling silver there's both silver and copper. So if we're looking for silver, that's going to be at the bottom here because we're looking for how much, which would be a weight. So that's going to be a total weight down here at the bottom. So our X here, which is going to be the silver, is going to be down here at the bottom. But then what we want to think of is the other part of the sterling silver, the copper, is what we want to put on this side over here, the percent of that in the mixture, and also the weight of that in the mixture. So that's what we're going to think about. We're going to think the silver we're looking for is only going to be down here. The other metal that's a part of that alloy is going to be in the other two places. So here we go. A percent of copper in the mixture is the 7.5% right here. So here's our mixture of sterling silver. It's 7.5%, which is 7.5 over 100. You can make that a decimal if you wanted to as well. Move that decimal back 2 places, 0.075. But we're going to want to make a fraction so we can cross multiply. So we're going to just put that number over 100. The weight of the copper in the mixture. Now we're looking at this right here, this 80-20 part, and the copper is 20%. So our weight is, we have 15 ounces, and it's 20% of those 15 ounces is the copper. So we got to multiply, make this 20% into a decimal, that's the 0.2, multiply that percent times the weight. That would give us the weight of the copper in the mixture. And then the total weight of the mixture that we're trying to figure out here is going to be 15. We have already 15 ounces. What do we need to add to that 15 ounces of pure silver? How much pure silver should you mix with or add to this here to make that sterling silver? So it's going to be the 15 you have plus however much pure silver you need to mix to it. So now that gives us a proportion that we can now cross multiply, and that's what they're going to show us how to do here. So 7.5 times our 15 plus x, 100 times these two, so actually three things multiplying each other. Distribute these two, 7.5 into these two here, 112.5 plus 7.5x. All of this multiplies to give you 300. So we'll subtract that 112.5. That gives us 187.5. Now on this side, divide by 7.5. So X is 25, which tells us that's how much of the pure silver. That's out in 25 ounces. We were talking about ounces here. 15 ounces, so this would be 25 ounces of pure silver needs to be added to the 15 to make that sterling silver then. Okay, so on your page 212, we're going to go ahead and try one of these. So on page 212, I'm going to have you copy this down. So actually copy the problem down. I know it's like 3 lines here you need to copy, but you really need to copy it down. You have enough space. There's a whole big page there. It's blank. Pretty much. Just put it right underneath the notes part there. So white gold is an alloy composed of 75% gold and 25% palladium. By weight, you have 12 ounces of an alloy that is 60% gold and 40% palladium. How much pure gold should you mix with this alloy to make white gold? So I have a ring over here that's a white gold ring. It almost looks silver, so white gold actually resembles silver, really, but it's actually made out of gold and this other substance called palladium, or palladium. I don't know how you exactly say that, but we're going to just go ahead and do the same thing as before. We want to make our proportion really out of this. Okay, so we're going to start with the percent. So we're going to start with the percent. I'll just put a little percent sign of the palladium. The percent of that in that mixture, and it's going to equal the weight. The weight of that palladium over the total weight. So far everything is palladium. Palladium over here, palladium over here. Down here is where we're going to have gold. Because it says how much pure gold should you mix to make this white gold. So we're trying to find gold. Gold is going to be our X here in this problem. So that's going to be down below here with the total weight. We already have 12 ounces, so basically 12 ounces plus X we know is going to be our total weight down here. So starting with the percent of palladium, that's going to be 25% is in white gold. So this is always going to be over here. This is the white gold on this side. So basically you have the actual kind of standard of mixture. So we have really kind of our white gold over here. This is basically the mixture that we have here in our possession. So what we're trying to get, or the standard, I should say, maybe here, and this is what we have. So we might want to put that down. So this over here is the white gold. This is what white gold is on this side for what the palladium says. And over here is kind of what we have. We have this over on this side. So now we're going to go ahead and put the percent of the palladium, that's the 25. I'm going to make it in just 25 over 100. So that's a fraction. And then over here, weight of that's going to be the weight of it. Well, we have 12 ounces. So this is what we have is the 12 ounces on this side over here. 40% of that is the palladium. So we want to say 40% is really 0.4. So it's going to be 0.4 or 0.4 times 12. That's the weight of the palladium that's in the mixture that we have. And then the total weight that we have here is 12 plus however much we're trying to put in for gold to make this into white gold. So that's what we're trying to do. So now we can just cross multiply. So we're going to see 25 times the 12 plus X is equal to 100 times the 0.04 times the 12. And so we'll distribute here 25 times 12. So let's see, 25 times 4 is 100. So it's going to be 300 then right there. 300 plus 25x is equal to, let's see, this is going to be, if I say 100 times this, that goes back to 40. And so basically we're going to see 40 times 12. for that. So 4 times 12 is 48. So that's 48 with a 0, so that's 480. And then we want to subtract our 300. And so that's going to give us, these are going to cancel. We're going to see 25x is equal to 180 here. And then we want to divide by 25. And so x is equal to 180 divided by 25. Let's go to our calculator. 180, that's not going to come out perfectly there. Divided by 25 is 7.2. So 7.2. So that's how many ounces. So 7.2 ounces here. Yeah, that's how many ounces then needs to be added. So 7.2 ounces, I guess we could say, of pure gold needs to be added to our mixture of this 12 ounces to make the white gold. All right, so let's move on to some more just solving the equations. Actually, first, let's just go take a quick break here for a second. Just a little joke of the day. What do you call cheese that isn't yours? I'm sure you've heard this one before. It's nacho cheese. Always a favorite one. Love that joke. Okay, so we're going to solve these equations with finding the LCD first, or using the LCD. So this is going to be a little bit different than cross multiplying. We can't cross multiply here because we don't have a fraction equal to a fraction. We got a couple fractions on this side equal to 6, or 2 fractions equal to another fraction, so we can't just cross multiply. So the other option then would be to use the LCD. We still want to keep checking our solutions just in case we get a solution that would be one of those excluded values. All right, so for number 5 here, our LCD between 7 and x is just 7x. So we want to find that LCD first and recognize that it is just 7x. And we're going to now multiply this entire equation by the LCD. That's how we do this. I'm going to put parentheses around the entire thing, and then we're going to be multiplying by that. Okay, so when we multiply our first fraction here, we can cross out the 7. That crosses with the 7 in the LCD, but then we still have an x to multiply the 4 by, so that one's going to get multiplied by an x. On the next one, we're going to cross out the x, and then we're going to have to multiply the 1 by a 7, but I'm going to actually make sure we see this as a minus 1 here, so I'm going to just change any minus signs to plus signs and then make that 1 a negative 1 then. So we're going to see, this is our 4x here. So we got 4 times x is 4x, and then inside here we got a minus 7, so minus 7 then after that. And then we're going to say equals 6 times the LCD. So we have to multiply 7x times this term as well. So that's 6 times 7x, that's 42x. Okay, so now everything is now equal to this fraction after multiplying everything here by the LCD. And now we're just going to go ahead and solve the rest of the equation. So I'm going to go ahead and subtract our 4x from both sides. That cancels out the 4x's over here, and now 42 minus 4 on that side is going to give us 38. So then we just divide by 38, so x is equal to a fraction of negative 7 over 38. We can keep that one because the only thing that x can't be is just the x can't be 0 from right there. I'm going to actually do number 7 next. So let's come down to number 7 right below this. LCD. So the first thing we need to see is that we need to make sure everything is in factored form. So these first 2 fractions are okay, but this last one here, we want to factor out an x from these 2 terms here because those have common x in them. So we want to see that as now x times x plus 4. So now our LCD again would just be, we can count most for each of these. Then we're going to have to put an x in our LCD, and we're going to have to put an x plus 4 in our LCD. So our LCD's got to have an x and an x plus 4, okay? Because this one we can make our LCD by just multiplying by x. This one we just need to multiply by the x plus 4. So this is actually the LCD. This has the LCD in it. So now we're going to put parentheses around the entire thing to show we're going to multiply this whole entire equation by our LCD. So for our first fraction, x plus 4 will cancel out with that part of the LCD, but we still have the x to multiply 12 by. So 12 is going to get multiplied by x. And here's where we have a minus 7. I'm going to make this really a negative 7 up there. So I'm going to change that to a plus and make this a negative 7 so we can see that. We're going to cross out the x at the bottom, and then we still have the x plus 4, though, to multiply this negative 7 by. So we're going to distribute negative 7 into this one. And then for 22, we don't need to multiply this one by anything here, because basically we're going to cross out the entire LCD. That crosses out completely. So we don't need to multiply 22 by anything. That's just going to come down. So for our first one, 12 times x is 12x, and then for this one we're going to see negative 7 distributed into that. So we start with negative 7x, and then negative 7 times 4 is negative 28, and it's going to equal that 22, like I said. So if we cancel out this here with our LCD, there's nothing left to multiply 22 by, so we can just bring down the 22. So now we need to combine our like terms over here. So we can say 12 minus 7 for those x's is 5x, and then add 28 to both sides. And so when I add 28 to both sides, it's going to cancel this 28, so it's going to get 5x equals, looks like 50 over there. So 5x is equal to 50. Divide by 5. So 50 divided by 5 is just going to give us 10. So our answer there is 10. And we can keep 10 because the only thing that x can't be 0, and x can't be a negative 4. So 10's fine. Number 6, our LCD for this one. So we have, looks like 2 different types of binomials. We have an x plus 1 and an x plus 2. So those 2 binomials are going to be the LCD. We just need to add, bring both of those into our LCD here. I can multiply this one by x plus 2, and these two I can be multiplying by the x plus 1, and that gives me the LCD. So I'm going to put the parentheses around the entire equation again. Starting with our first fraction, we're going to cancel out the x plus 1, and we still have a x plus 2 to multiply this 3 by here, so putting that there. And it is a plus here. We're going to cross out our x plus 2 with the x plus 2 in the LCD, but we still have to multiply x plus 1 times 4. And then for this fraction, doing the same thing, crossing out x plus 2 and then multiplying 15 times x plus 1 as well. And so now once we do that, we're going to multiply all these to get our new equation. So just distributive property with each of these. So this first one's going to be 3x, and then 3 times 2 is 6, so plus 6. And then 4 times x is 4x, then 4 times 1 is 4. So plus 4, then it's going to be equal to 15x from 15 times x, and 15 times 1 is 15. And so now we can combine like terms over on this side here. So I got 7x when I put those together and a 10. So 7x plus 10 is equal to 15x plus 15. And now we want to get the x's on one side, so we can be canceling out our 7x's, or subtracting 7x from both sides. So they cancel on the sides. Now it leaves me with 10 here. 15 minus 7 will be 8x and the 15. And so now I can bring the 15 over to where 10 is, subtract 15 from both sides. So now this is going to give me negative 5x is equal to 8, or since negative 5 is equal to 8x over here. These 15s cancel. And so now I just divide by the 8. And so that's going to give me an x is equal to a fraction of negative 5/8. And we can keep this one because there's only 2 numbers that x cannot be. That would be negative 1 and negative 2. And this is neither one of those. And our last one here on this page, number 8. So our common denominator, LCD, is just going to be x and the x minus 1. Those 2 times each other will be our LCD. And so we start to multiply in. So I'm going to put parentheses around the entire thing. So this right here, the 3, has nothing underneath it to cross out either one of these. So we're going to have to multiply this 3 by both of this. This whole thing gets multiplied by 3. So basically 3 times this, we'll just put the 3 in front of the x. So we could do that. For the second fraction, we'll be canceling out the x minus 1. We still have to multiply x times 18. Let's go ahead, and since this is a minus, let's make this a plus and make that negative 18 there. So we're going to multiply it by x, but I want to see that as a negative 18 times x, or negative 18x. And then this one we're going to cancel out the x at the bottom, but there's still an x minus 1 to multiply the 12 by, and this is a negative 12 here, so we need to recognize that that's a negative 12. So I'm just going to show the negative sign up here. So now as we start to put down our equation, 3 is going to go in front of this whole LCD. So 3x times x minus 1 is that first part. So multiply 3 times this whole thing, so it just goes 3 in front of the x. Then we have a negative 18x to go for that second fraction. And then it's going to equal this distributive property, negative 12 times x, so it's going to equal negative 12x. And then negative 12 times negative 1 is positive 12. So we still have to do a distributive property here with 3x. So 3x times x is 3x squared. And then 3x times negative 1 is negative 3x. And then just rewrite the whole rest of the equation. So the negative 18x comes down, equals negative 12x plus 12. Alright, so what we see now is we have a quadratic equation with the x squared here. So we want to get these two terms over to this side so that way it's equal to 0. You always want, when you see an x squared, you want to always set it equal to 0 for standard form. So now what we want to do is go ahead and add 12x and subtract the 12. So we'll do that kind of first. Adding 12x cancels there, subtracting 12 cancels here. This now is going to be 0. So now on this side we're going to add 12x to this x term. Actually, there's two x terms here. So negative 3 and negative 18 and a positive 12 will all combine together. And then negative 12 just be behind that. So these three terms are going to combine together here. This makes negative 21, and then take 12 away from negative 21. So our trinomial should now be 3x squared. We're going to put over here 3x squared minus 9x. So that would be basically 21 minus 12 is 9. So it's a negative 9 because there's more negatives. And then the negative 12 goes behind that, equal to 0. And what I notice here is that I have 3, 9, and 12, and 3 can be going into all those numbers, so we can reduce this whole thing by 3. So now I'm going to make this a smaller trinomial equation to factor. So I'm going to reduce everything here by 3. So I'm going to factor out 3. So that leaves me with an x squared, negative 3x, and a negative 4. Now this 3 that I factored out, since it doesn't have an x, we don't need to worry about that anymore. We just need to factor what's inside here where the x's are. So that's going to factor to two binomials. The two numbers that multiply to give you 4 and subtract to give you 3 be 4 and 1. So that's going to become an x minus 4 and an x plus 1. They got to be different signs. The bigger one's going to be negative. So 4 is negative and then the 1's positive. You can always double check that with FOIL. So at this point we want to set each one of these separately equal to 0. So the first one equal to 0, we can add 4 and find that x equals 4. So there's one answer. And the second one, we're going to say x plus 1 equals 0 and subtract 1, and so x equals negative 1. And if we look at our excluded values, x cannot be positive 1 and x cannot be 0. So that means these two numbers are okay to keep. Alright, so let's move on to our next section. I said we were going to do half this lesson. I decided to just do the whole thing all at once here and maybe shorten it up a little bit. So let's move on to number 9. Okay, so for number 9, we're doing the same thing, finding the LCD. So basically 9 to 12, doing that same method of just finding the LCD, multiplying by the LCD, and then solving the equation that's left. So on this one, our LCD, we need to factor this x squared minus 5x because there's an x in both of those. So we need to see that as x times x minus 5. And we have an x and an x minus 5 over here. So that is just our LCD, is just x times x minus 5. So this is the LCD on this one. And so we can now multiply this entire equation. Starting with the first fraction, the x minus 5 can cross out. And so the x that's left here is going to multiply the 2. So 2 times x on that first fraction. And we do have a plus on this next one. The x is going to cancel out, but we still have to multiply x minus 5 times this 3. So we'll put the x minus 5 next to the 3. And since this one here on the last fraction, the entire LCD would cancel out, there's nothing left to multiply 10 by, so we'll just see 10 coming down on its own. So starting with 2x, 2 times x is 2x, and then we're going to see plus 3 times x as we distribute 3 in there, so plus 3x, 3 times negative 5 is negative 15, and it's going to equal 10 from this other fraction, this last fraction. So we're going to see that's a 5x right there. 5x minus 15 equals 10. We'll add 15 to both sides, and it's going to give us now 5x equal to 25. and just divide by 5, and so x is equal to 5. But notice I have to cross that out. I can't keep 5 because that's one of my excluded values here. So one of the excluded values is x cannot be 5 and x cannot be 0. So since we got an answer that was an excluded value, we have to cross it out. Since that's the only answer we got, we then have to say that this problem has no solution. There is no solution to this one. All right, so number 10, our LCD. We notice we have a trinomial in this second fraction. We're going to have to factor that to two binomials. So just using the simple method, what two numbers multiply to give you 4 that add to give you 5, that's just going to be 4 and 1. So we're going to have to start to see that this is going to be x minus 4, x minus 1. They're the same sign, they're both negative. That's why it's a negative 4 and a negative 1. And that's what we have over here. We have an x minus 4 and we have an x minus 1, so that means that this is the common denominator. That is our LCD. So we can just say x minus 4, x minus 1 is our LCD. Let's put parentheses around the entire equation here to multiply. So this first fraction, we're going to cross out the x minus 4 with the x minus 4 in the LCD. But then there's still this x minus 1 to multiply this numerator by. So x plus 6 is going to get multiplied by x minus 1. And then we need to see that on this one, we're going to cross out the entire LCD. And so there's nothing left to multiply 30 by. But we do need to realize it says minus 30. This 30 really is a negative, so you might want to change that to a negative 30 so we don't make that mistake on a sign error here. And the last one, we're going to cross out the x minus 1, and that leaves us still with an x minus 4 here in the LCD to multiply this 3 by. So next to 3, I'm going to say multiplying by x minus 4. So now let's do that multiplying here. So we have to use FOIL for this first one. So x times x will be x squared. And then the outside is going to give me negative 1x, the inside positive 6. 6 minus 1 will be 5x then, so plus 5x. And then your last terms here would be 6 times negative 1, that's a negative 6. Now we're just going to put down our negative 30, bring that negative 30 down, equal to 3 times x is 3x, and 3 times negative 4 would be negative 12. So we do have a quadratic again, so it means we want to get everything on this side where the x squared is. We notice we can combine this to make negative 36 here. We're going to also be subtracting 3x, we're going to add 12 to bring those over as well. So as we start to do that, we're going to cancel out the 3x when I subtract 3x, add 12 and cancel those out, and bring them over here. So now we have this negative 3x is going to combine with this 5x. The 12 will combine with these two, that's going to be negative 36 plus a 12. So we're going to see x squared coming down, this will be a 2x. If I think of this as negative 36 and take 12 away, that's going to be negative 24. So there's our trinomial equal to 0. We want to see if we can factor that with two numbers, multiply to give you 24, that subtract to give you 2. That would be 6 and 4. So we can say x in front of each of the binomials with a simple method, and put in your 6 and 4. They're different signs. The bigger one, which is 6, is going to get the positive, which means 4 gets the negative. And then we want to set each of those separately equal to 0. So x plus 6 equals 0, and then we can subtract 6. X equals negative 6. And we can keep that one because that's not one of the excluded values. Remember, our excluded values would be here. X can't be 4, x cannot be 1. So our next one here would be x minus 4. When we add 4, we do get x equals 4, so that's an excluded value. We're going to have to cross that one out. We can't keep that one. So the only answer on this problem then is just that x is equal to negative 6. It only has one answer then. Just keep the one that you can keep. All right, so number 11. On this problem, we see a trinomial on this last fraction. We're going to have to factor that first before we get started with the LCD. So factoring that would give me x minus 5 and an x plus 2. And so again, starting with x squared, x is going front. The two numbers are 5 times 2 for 10, and 5 minus 2 would give us the 3 because we got to subtract to get 3. And they're different signs. The bigger one's going to get the negative. That way 2 gets the positive, and it is the same 2 as over here, so that kind of helps out. It kind of guides you and say, oh yeah, that makes sense. These two are the same, which means that this is the common denominator. Our LCD is just that. So we're going to put parentheses around the whole entire thing. We're going to multiply each of these by the common denominator. We're just going to see it here. I'm not going to write it on this one. So for this one, we're going to cross out our x minus 5, but we still have to multiply x plus 2 times this x. So that one's going to get times by x plus 2. This one we're going to cross out the x plus 2, but we need to multiply this one by an x minus 5. And this last one, we would see that we don't need anything to multiply 11. We already have the common denominator underneath as well. So the 11 is just going to come down. So our distributive property here, we're going to see x squared first, and then x times 2 is 2x. Then we're going to see plus here, so that's not going to make that any different there. So 2 times x is going to be positive 2x. 2 times negative 5 is negative 10, and it's going to equal the 11 from this last fraction. So now we can put these two together here. Since it's a quadratic, we want to bring the 11 over as well. So we want to actually subtract 11 from both sides. So we're going to do that first and combine these two together to get 4x. So we're going to see x squared of 4x, and this will be negative 21. And that will be equal to 0. And then we want to factor this to two factors. This should be able to factor. 7 minus 3 is 4. 7 times 3 is 21. 7 minus 3 is 4. So the 7 and 3 would work. So it's the x's up in front, the 7 and 3. They are different signs. The bigger one's positive, so 7's positive. And then set each factor equal to 0 separately. And just remember our excluded values on this one would be x can't be 5 and x can't be negative 2, as we're starting to get to our answers here. So x plus 7 equals 0. Subtract 7, we get negative 7. So we can keep that one. And then x minus 3 equals 0, and we add 3. And we can keep that one, x equals 3. Alright, so we have two answers actually on this equation that we can keep. Now number 12, I'm going to skip that one for now. I might come and do that one in class. That's going to be a little bit longer of an equation to do, so I'm going to save some time and just skip that one and move on to the next section. Okay, so this number 13 and 14 takes us back to looking at the inverse functions. We've kind of been doing that almost in every chapter, looking at inverse functions. It says determine whether the inverse of f is a function, then find the inverse. So we're going to see that we can do this. Let's find the inverse first. So let's go ahead and find the inverse, then we'll talk about whether the inverse is a function. So first of all, we need to remember that there's a two-step process for this. Hopefully you remember this. It's very simple to remember. Switch and solve. I always like to say switch and solve. That's when you find the inverse, switch and solve. So we want to do that. Switch, then solve. We're going to switch x and y, then solve for y. That's what we're doing. So remember, switch and solve. So first of all, we need to realize that f of x is where our y is. That's our location for the y. That is the y. And so when we want to switch now, we're going to just switch the x and the y. So now it's going to be x equals 8 over y minus 3. And now we need to solve for y. So the first thing I need to do is, kind of see this. How do I get this out of the fraction? Well, what I could do is I can put this x over 1 and make that a fraction. So now it's a fraction equal to a fraction, and that's a proportion where we can cross multiply like we did on those first few problems. So I can see I'm going to cross multiply here, x times this binomial of y minus 3, 8 times 1. So on one side we're going to get x times the y minus 3 equal to the 8 on the other side. And we're trying to solve for y, so I want to get rid of my x now. I could divide both sides by x. So I can divide by x, and now that would cancel my x's out here, where y minus 3 now is equal to 8 over x. And now I just need to get rid of this 3, move the 3 over by adding 3 to both sides. And once I do that, add 3 to both sides, I cancel the 3's out here. So y is now equal to 8 over x plus a 3, and there's my inverse. I'm going to say y to a negative 1. The little negative 1 to show that's the inverse that we're talking about here. We could also put f of x to that negative 1, and same thing. So 8 over x plus 3, that's the main part of what the inverse is. So let's talk about whether that's a function. There's two ways we could do that. We could now graph these on the calculator, and we want to see what the graph looks like. And so we could either graph the inverse and see if that's actually a function itself using a vertical line test. We would need to use a vertical line test if we're going to graph the inverse here. Or we could graph the original function here and use a horizontal line test and see if that's going to work. So it doesn't matter which one you do. Let's go ahead and just graph this one. I kind of like just remembering the vertical line test. That helps me just kind of keep that straight so I don't get confused. So I'm going to just look at it and see, is this a function right here, 8 over x plus 3? So I'm going to go to Desmos and type in our 8 over x plus 3. So let's say 8 divided by x. That's our 8 over x, and then I'll put plus 3, and there it is. So I need to take a look at this. Let's view this a little bit better. So using my vertical line test, if I took a vertical line and swept it across the screen there, I'm only going to touch one point of our graph at a time, because remember this right here, the y-axis, would be where the asymptote would be. It's not touching there either. So this does pass the vertical line test. If you touched your graph, this red line here, more than once with a vertical line anywhere, then that would fail the vertical line test. So since this one passes, we can say that yes, this is a function. It passes the vertical line test. All right, for number 14, remember the f of x is our y, so we make that our y. Switch now and then solve. So switch x and y, so it's going to be x equals 12 over y plus 9. And now we solve for y. The first thing we got to do is move our 9 to the other side. So subtract 9 from both sides. So now we get x minus 9 is equal to the 12 over y. And now we need to, kind of see this as we need to get rid of this. So we need to kind of multiply by y. We could do that. So we can multiply by y first. So that would be y times x minus 9. And then we can divide by x minus 9 to get the y by itself. So now I'm going to go the other way and now divide by x minus 9. And that would cancel the x minus 9 out here on this side, leaving me with just the y by itself. So now we have 12 over the x minus 9. That's our inverse function. So y to the negative 1, showing that's the inverse notation, is 12 over the x minus 9. That's the main part of what the inverse function is. And so I can just graph this part by itself to see, does it pass the vertical line test for this one. So if I needed to figure out whether, before I needed to do this, if I needed to figure out if it was just a function, I could graph this one, but then I'd have to check it with a horizontal line test to see if that's a function. So let's go back to Desmos over here. Let's go ahead and get rid of all of this and type in our new one. So our new one is 12 over x minus 9. So let's go to put 12 divided by, and I'm going to put in parentheses, x minus 9. X minus 9, close the parenthesis there. So that's what I'm looking for. And as we look at our graph here, it does pass the vertical line test. It's not touching two places at one time. It's only touching one place at a time. Even when it gets to right here, there's an asymptote, so it's not going to touch two things at one time, even right there. So yes, this passes the vertical line test, which means yes, this is a function as well, passes the vertical line test. All right, let's go on to our last problem. Okay, so we are number 15. This would be considered a work problem. The one we did earlier, that was considered called a mixture problem. You don't want to write that down over there back on page 212. You can write just mixture problem, and then maybe next to this one on 15, write work problem. This is a work problem. So these are two popular problems that a lot of times they like to give you, especially on standardized testing. So you can complete the yard work at your friend's home in 5 hours. Working together, you and your friend can complete the yard work in 3 hours. How long would it take your friend to complete the yard work when working alone? It says let t be the time in hours your friend would take to complete the yard work when working alone. So we're going to see this. I'm going to show you this in two ways. First of all, we're going to do this, but then I also want you to see how you can do it another way as well. So a lot of times they ask you to do it a different way, where you want to find, usually if you know what both you and your friend can do it by yourself, how long would it take you working together? That's often usually the way it's written out. So I'm going to show you that way as well. But first of all, we just need to figure out how long is it going to take your friend to do it by himself. It says you can do it in 5 hours. So your friend, how long is it going to take him? So this is going to be the same idea where you're doing 1 yard in 5 hours, and together you're working here. It takes 3 hours. That's you working together. So really, what we see up here with work rate, time, and the work getting done, we want to realize that we're going to multiply work rate times time, and it's going to equal the work getting done. So write that in there. Work rate times time equals the work being done. And for your friend, he'd be doing 1 yard in t amount of hours. We don't know that. That's what we're trying to find. Actually, I'm showing you this here. You'd multiply this, I'm sorry. So 1/5 times 3 is 3/5. There, let's make sure we multiply that. Now we can do for your friend here, he's going to be 1 yard in T amount of hours, so 1 over T. So it's 1 yard in T hours. We don't know what T is. That's what we're trying to figure out. So he's going to be multiplying 1T over times a 3. So that's just going to be 3 over T. So 3 over T on that one. This one you can see is going to be 1 times 3 is 3 on the top, 5 is still on the bottom. 1 times 3 is 3 on the top, T is still on the bottom. So now what we see here with the work being done, the next thing you want to know here is that these two, you and your friend, added up will equal 1 job getting done. Because you're going to do it, he's going to do it, that will equal 1 job getting done. So the two of those will equal 1. So these two added together equal 1. So we can now write an equation with 3/5 plus 3 over T is equal to 1. So that equation is here. And we want to see, okay, what's our common denominator here? Because that's what we would have to do. We'd have to use our LCD, which would be 5 and times T. 5T. We need a 5 and we need a T to multiply here. So 5T is the LCD. When we see our first fraction, we're going to cross out the 5, but then we still need to multiply T times this 3. So, and then we do the next thing on this one, cross out the T, but we still have to multiply 5 times this 3. And then this 1 is going to be multiplied by the entire 5T. So for our first one, this is going to be just 3T. For the next one, it's going to be 3 times 5 is 15. And for the last one, 5T times 1 will equal 5T. And so now we can maybe subtract 3T from both sides. And so when we do that, we'll subtract the 3T. This will now be 2T on this side. 15 equals 2T. Divide by 2. And so 15 divided by 2 as a decimal would be 7.5. So T is equal to 7.5. That's how long your friend would take to do it by himself. 7.5 hours. Apparently your friend is a slowpoke, according to compared to you. Now I wanted to show you this one more way. So if you still have some room, hopefully you still have some room, you might want to go back to page 212 to write this down as well if you don't have room. But the other way they often want you to figure out is, what if we didn't know how many hours you could work together? So we knew that you could do it in 5 hours, and we knew your friend can do it in 7.5 hours. But how long is it going to take you doing it together? How would we get this 3 in here? So that's what we want to see next. I'm going to kind of just put the chart down below here using the same thing. So he's got the 1/5 again for you. We have 1 over 7.5 for your friend. We don't know the time and how long it's going to take you two working together. So that if we didn't know that, both of those would be x. And now when we multiply across, we're going to see 1 times x is going to be x over 5. And 1 times x again is x over 7.5 for your friend. And now these two added together would equal 1. And so we could say those two added together will equal 1. So that makes this equation basically here, the x over 5 plus the x over 7.5 equals 1. And our common denominator would have to be 15. Because 5 goes into 15, 7.5 also goes into 15 2 times. So now we can see, well, 5 is going to cross with 15, but there'll still be 3 left, because 5 goes into 15 3 times. Still 3 left to multiply this x by. 7.5 goes into 15 2 times. Still 2 left to multiply this x by. So now our equation would be 3x plus 2x equals 1 times 15. And so that's what our equation. We can then see, well, you can combine like terms there. So 5x equals 15 and divide by 5. And 15 divided by 5 would be 3. And now there would be 3 hours. That's how we could get this 3 here for how long would it take you working together. So if you know how long you can do it by yourself and you know how long your friend can do it by yourself, this would tell you how long you can do it by working together. That's often the way they usually present the problem. So, all right, that concludes this lesson on 7.5. So you want to go on to the Big Ideas assignment and complete that, and then you should be ready for starting the quiz after that. All right, I'll see you back in class.